Okay, so we're going to talk about naming binary compounds. Binary compounds, binary just means that there are two elements or two atoms there. So really, we're going to go from formula to name first, and then we're going to take from the name and create the formula. All right, so our first example here, we're going to take LiCl. All right, we're going to talk about naming these compounds. The step number one, you're going to name the metal. Okay, the metal is always written first. Okay, so it's pretty simple. You're going to name the first element. First element right there is Li. You look on the periodic table. If you haven't figured out what Li is, through common usage yet, Li is lithium. So, example is LiCl. So the first thing we have is lithium. Step number two. You're going to take the root of the nonmetal and add the letters IDE to the end. So the suffix "ide" to the end. Okay, and this is going to take a little bit of work to determine roots. Okay, and it's just through work and repetition. So we have LiCl again. All right, and then we have lithium already from the previous step. All right, and then our root here, our non-metal is chlorine. Okay, so we're going to take the root word of that, which is chlor, and we're going to add IDE. So we're going to take chlor, which is our root, and we're going to add IDE. So your answer here is lithium chloride. Okay, lithium chloride. You take the name of the metal and you add IDE to the end of the nonmetal. Okay, let's do another example. All right, now, you may be looking at this and going, okay, well, what about the two? Okay, in binary compounds, really ionic compounds in general, as far as naming goes, they don't matter. Okay, subscripts don't change rules. Okay, so the subscripts, which is that right there, the little number, does not change the naming rules. So let's look at this one. What's our metal? Our metal is right there. Mg, look it up. It's magnesium. Okay, and again, Cl is chlorine, so we're going to take the root word chlor. All right, and then we're going to add IDE. So chlor and then ide. Okay, let's do another example. Let's do K3P. All right, and then we'll talk about how we get those subscripts here in a second. So K, look it up on your periodic table. K is potassium. P is phosphorus. So you're going to take the root word, which is phos, I guess. And you're going to add IDE to it. So potassium phosphide is your answer there. All right, so it's the metal, and then the root, IDE. Same thing every single time. All right, and then one last example real quick. We'll go Ca3 and 2. Again, the subscripts don't matter, all right, as far as naming is concerned. So we're going to go calcium, and then N is nitrogen. So there's your root. And there's IDE, so calcium nitride. Okay, that is taking the formula and coming up with the name. Okay, so let's do it the other way. Let's go from the name to the formula. Okay, that takes a little bit more. It takes a little bit more work. All right, so let's take an example of beryllium chloride. Okay, beryllium chloride. Step number 1 is to write the element symbol for each element. Okay, so the element symbol for beryllium is Be. The element symbol for chlorine is Cl. So step 1 is done. All right. The one thing I'll tell you about naming, it's very procedural. If you follow the procedures, there's no way you can get it wrong. 2. All right, you have to identify the charges. And this is where your periodic table comes in handy. You're going to look at what group these things are in. All right, so Be is in the second group, okay, the second column, so it's going to create a +2 charge, like we talked about in the last video. So you got Be2+. Chlorine is in the 7th column, so it's going to create a -1 charge. So you have Be2+ and Cl- now. Okay? Step number 3. Okay, step 3, you're going to cross the charges. Create subscripts. All right, so you're going to cross charges to create subscripts. So I'm going to show you what that looks like. You've got Be, I don't know what that is. You've got Be2+, and you have Cl-. Okay, so what I mean when I say cross the charges. All right, these charges right here are going to become the subscripts. So you're going to move this over down here. You're going to move this -1 over here. All right, and once you've done this, just one little thing, all right, the signs don't matter. All right, so the fact that this is a +2 right there doesn't make any difference. What we're interested in is the fact that it's a 2. Okay, so they're going to become our charges. So we've moved right here. So now we've got BeCl. Okay, this right here, this -1, came all the way down to be the subscript for Be. Now, it would be a 1, but you don't have to write a 1. It's understood. The fact that we have a Be there tells us that we've got a beryllium atom. You don't have to write the 1, okay? But I'll write it just for right now, okay? And this 2 right here, this 2+, again, the charge, the fact that it's a positive doesn't make any difference. We're going to bring it down and make it our subscript for chlorine. So now our answer is BeL2. That's the formula for beryllium chloride, which is what we were trying to do in the first place. Okay, so let's do some examples. Okay, one other thing here. So we have that signs don't matter, and number 1 does not get written. It's understood. All right, it's understood. Just like in math, you don't have 1x, you just have x. All right, so let's do some more examples. Let's do sodium nitride. All right, and remember, we're taking in the naming, we have the "ide," but this is what you're looking at, the root. So nitride is nitrogen. Okay, so sodium is Na, and then nitrogen is N. So you're going to look at the periodic table, and you're going to see that sodium is in the first group, so it's going to get a +1. You're going to see that nitrogen is in the 5th group, so it creates a 3 minus charge. Okay? Take the charges, take the numbers, cross them down, and you end up with Na3. Okay, we don't need the minus sign, and just an N. We don't need the 1. So Na3N is your answer there. Another example. Potassium oxide. Oh, I'll give you the answer. All right, so potassium oxide. Potassium is a K. Oxide is oxygen, so that's an O. All right, so you have K and an O. You're going to see that potassium is in the first group, so it gets a plus. Oxygen is in the 6th group, so it gets a 2 minus charge. Again, you're going to cross these to create the subscripts. The charges create subscripts. All right, and then you end up with K2O. All right, now let's do one a little bit different. Magnesium oxide. All right, magnesium is Mg, oxygen is O. All right, when you look at their charges, it's a 2 plus and a 2 minus. We're going to do a little math here. We're going to cross these charges to make the subscripts, and we're going to get Mg2O2. Right now, this is correct in that you have made the charges the subscripts, but it is not correct because it is not simplified. Okay, in ionic bonds, we want to simplify these things. All right, so just like in math, you're going to simplify it, divide it by the greatest common multiple or whatever you call it in math. It's going to be MgO. Okay, so MgO is going to be magnesium oxide. Do not forget to simplify. Okay. Ionic compounds must be simplified. Okay? That's how you make ionic compound formulas, binary anyway, and names.